In this section, we are going to learn about the basics of programming. The skills you are going to learn in this section you will be able to take to any other language that you may want to learn. We are going to cover setting up a simple Rust program and then building and running it. We will also discuss variables, data types, conditional statements, functions, and a whole lot more. Please feel free to ask me any questions you may have as we go through this section. In this lecture, we're going to talk about how to set up the infamous Hello World program. If you're new to programming, Hello World is just the industry standard first program you create to get your feet wet and make sure your environment is running properly. It's just going to be a super simple program that will output Hello World to the console. All the code that I do throughout this course, I will push to GitHub, and I will leave the link to this in the resources tab. So the first thing that I want to do is show you an extension that I installed. It is just called Rust. It'll be the first one you type in the extensions marketplace. Just type in Rust and it'll be the first one. It's version 0.7.8 is what I have installed currently. So the first thing that we're going to do is type cargo new hello. And what that did is that created us a new directory called hello. So what is cargo? Cargo is Rust compilation manager, package manager, which is kind of like pip in Python, and it is Rust's general purpose tool. You can use cargo to start a new project, build and run your program, and also manage external libraries that your code is going to depend on. Inside this hello folder, you can see that we have a cargo.toml folder, and all this holds is just a metadata, which is just a fancier word for information for the package. We will cover cargo a lot more in depth later on in this course. So now if we look inside of the source folder, we see we have main.rs. Main is the file that is going to basically be the centerpiece to creating your binary. So whatever is inside of main, that's going to be the entry point to running the program. So what we can do is cd into hello and run cargo build. So now we built the program and it generated a new file for us called target, and inside here we have a bunch of different folders that were created, but the main one is hello.exe, and that's going to be our executable. So now we can run cargo run, and it's going to automatically go in and run the executable for us, and as you can see, we have outputted hello world to the console. So congratulations on creating, building, and running your first Rust program. So in this lecture, I just want to make sure that everybody understands how to use Visual Studio Code for this course. So the first thing that we want to look at is making sure that we have the same extensions installed. So if you click on these boxes over here, and if you highlight over it, it'll tell you that it's extensions, or you can hit Control-Shift-X at the same time, and it'll bring up all your currently installed extensions, and then you can also search for extensions. So we're going to search for Rust, and this is the official Rust extension for Rust. So this is the one that I went with, but you can see that there's plenty more over here that you can install if you want to check out different ones and find the one that is right for you. But I am using this one. It's just called Rust. It's version 0.7.8, and that is the latest one. And then once you install it, you can just restart Visual Studio Code just to make sure that the install has taken effect. And once you've done that, you do have your Rust extension completely installed. So I provided all the source code in a zip file. If you want to open it, all you have to do is unzip it, and then you can go to File, Open Folder. I have mine on my desktop, and then you just select Folder. And inside of here, you will see all the source code for this lecture in this folder. And it's important to make sure that you change directory into it. So for me, it's just CD and then Rust the Complete Guide. And then just change directory into any of the folders depending on what lecture you are on. And then it'll run as normal. And of course, the one that I picked happens to be of a section 2, cargo run. Could not find, what do we have in here? So we'll go to hello, and now we have our cargo.toml file, so now we can do cargo run. So as you can see, as long as you change into the directory inside of the folders to the location where your cargo.toml file is, then you can start running cargo run, and the project will compile successfully for you. So if you want to change folders, because maybe you have created your own folder for writing the source code from scratch, well, you can close the folder by just going in here and selecting Close Folder, and then you can open up your own personal folder, which I created one called Rust Project. So we'll select it, and as you can see, my folder is currently empty. So up here in my version of Visual Studio Code, which is the latest version, I update it every time that there's an update. You can toggle this panel down below, and it'll bring up the terminal for you, or you can hit Control-J to toggle it on and off. So in here, we want to create a new project, and we'll just call it Hello. And now you see that Cargo New created a new folder for us called Hello, and we want to CD, change directory, into that folder, and you'll see we have our cargo.toml and our source folder already created for us. And now if you execute cargo run again, you see we have Hello World executed, which is the intended output for our templated new cargo package. So hopefully this clears up anything, and if you have any more questions, please ask them in the Q&A section. But this is all you need to know on how to use the Visual Studio Code IDE for this course. So enjoy the course, and if you have any questions at any point, please ask them in the Q&A section. In this lecture, we're going to talk about variables and mutability. Variables are how we are going to store the data that is necessary for our application to run, and then mutability is going to refer to how that data can be manipulated. If it's mutable, we are able to modify the variable, but if it's immutable, we will not be allowed to modify it. So to demonstrate this, we're going to create a new directory called variables using cargo, and we're going to change into that directory. So now if we look at the folder structure, it is the same as what we're used to, especially with hello. So we'll go into main.rs and we will delete that line. So the first thing that we're going to do is use the let keyword, and this is basically saying, hey, this is going to be a variable. So we're going to say let x equal 5. And then we're going to use the print line macro, which is going to allow us to print information out to the terminal. We'll cover macros more in depth later on, but for now just know that print line with the exclamation point is how you print information out to the terminal. So we will say the value of x is, and then curly brackets, and specify the variable that we want to print out. Also, if you're not super familiar with Visual Studio Code, if you click File and go down to Autosave, it'll automatically save for you. That way you don't have to continuously do it. Now if we run cargo build and cargo run, we get the desired output of the value of x is 5. So now what happens if we try to assign 6 to the variable x and then print out the same value? So we will build it again and we get an error. So if we bring this up, we can see that the error says cannot assign twice to a mutable variable x, and it'll tell us that at line 2 we first assigned to x, and then at line 6 we're trying to reassign to x. But it also says consider making this binding mutable. So if we come up here and put mute x, our error for that squiggly, that was at line 6, so just so you can see it again, how it has it here. So now if we put mute, that error is now gone. So if we build it again and then run, we now have the desired output. So what this keyword right here is doing is it's allowing us to be able to modify the x variable. So that's really important to know, because if you forget that mute keyword, then you're not allowed to modify any variables. Another keyword that we can use to make sure variables are not able to be modified is const. Const is going to allow the variable to live as long as the program is alive. So what we'll do is we'll create a const called seconds, and we'll assign it the data type of I8, and I'll get into data types in the next lecture. Now, by Russ's naming convention, constants are always going to be in all capital letters. So anytime you see a variable in all caps, it should be a const by Russ naming convention. So what we'll do here is we'll print out again the value of seconds is seconds, and we will cargo build, cargo run, and we see the value of seconds is 60. So constants cannot be mutated at all. So as you can see, it's already complaining about it. Const globals cannot be mutable. So luckily Russ is really friendly with telling us all of this information, but it's all very important beginner steps on knowing how to instantiate a variable. So in the next lecture we will talk about data types. In this lecture we're going to discuss data types, and we're going to start off talking about what scalar types are. And scalar types represent a single value, and Rust has 4 primary scalar types, and they are integers, floating point, booleans, and characters. So what I went ahead and did is I used cargo new to create a new directory called data types. And in here we're going to look at integers, integer literals, floating points, booleans, and characters. To start off, we're going to start off with integers. And integers can be 8-bit, 16-bit, 32-bit, 64-bit, and 128-bit. So if we wanted to create an 8-bit integer, we can say let x of type I8, which is going to stand for integer that is 8-bit, equal, and then for this we'll just do 10. So now if we just went ahead and printed this out, we would get 10. So now we'll go down here, cargo build, and cargo run. And as you can see, 10 was printed out at the bottom. So now integers can also be signed or unsigned. And what that means is that if it's signed, it can be positive or negative. But if it's unsigned, that means it won't have a plus or minus. So only use unsigned integers if the value you want is for it to always be positive. So it works the same way. So we'll say let y, and then we'll do u for unsigned 8. And right here you can see where we have all of our unsigned bits as well. So we have 8, 16, 32, 64, and 128. So we'll do 8 again, and then we'll just enter this one to also be 10. So this is creating an unsigned 8-bit integer. So no matter what we did, it will always be positive. So the next thing that we can talk about are integer literals. So what we'll do here is we'll create a variable called decimal, and we're going to assign it to 02_55. So this is going to create a variable called decimal, and it's going to contain a value of 255 in decimal format. So we can also do this with hex. So if we do that, create a variable called hex and assign it a hex value, that will also be 255. Correct that typo. Nope. There we go. And likewise, we can also do this with octal. So we'll do octal as well, and it'll be 0 with a little circle, with a little O. There we go. And do 377, which will also be 255. And then finally, we can do binary and set it to 0B1111_1111, and that will be 255. So now if we went ahead and printed all of these out, and then for sake of time, going to copy and paste, and we will go decimal, hex, octal, and binary, cargo build, cargo run, and as you can see, we have 255 for all of those above. Another one that I can point out is a byte. So we can say let byte equal lowercase b apostrophe big A, close it off. And this is going to print out the ASCII value of what a capital A is. And I believe it is going to be 64 or 65, and it is 65, as you can see right there. So now what we're seeing right here, and this is just a little tidbit, we created a y value, a y variable, and we never used it. So if you want to silence these unused variable warnings, you can put an underscore in it. So now if we cargo build and cargo run, it's a completely clean, all the warnings are silenced. But we could also comment it out with 2 forward slashes, and it'll turn the text green. That's pretty universal in programming languages on how to comment in your code. So what we'll do is we'll comment all this out, and we'll go down, and now we're going to look at floating point. So floats are going to work a lot like integers in the way you instantiate them. So what we'll do is we can do it this way. So we'll do x again equals 2.0. And what this is going to do is it's going to create an F64, which stands for float 64 bits. And this is default because on modern CPUs, it's roughly the same speed as a floating point 32. So if we wanted a floating point 32, we could do it this way, and it's the same thing. But floating point 64 obviously is going to give you better precision. So that's why it's default. Next, we will look at Booleans. So Boolean is just going to be true or false. So the way we can do that is let T for true equal true, and then let F Boolean equal false. Either way works. They both are the same thing. So the reason that this works is because Rust compiler and runtime is smart enough to infer the type. So it's going to know, okay, hey, the variable t is set to true, so I know that this variable is always going to be a Boolean. So you can implicitly tell it with that, or you can let it figure it out on its own. Either one works, kind of a preference. And lastly, the next one we're going to look at is a character type. So we'll do let C for character equal C. And it's the same thing. So if we wanted to print that out, and we'll put that in there. Clear it off, build it, run it, and as you can see down here, we printed out this C character. Now there's a couple of arithmetic operators that we have. You have plus, minus, multiply, divide, and then remainder. So we'll create a couple of variables. 10, let b equal 5. And then what we'll do is just demonstrate what the remainder is. 10 plus 5, we all know how that one's going to work. So just for sake of time, we'll do a remainder. So we're going to change b to 4, and we'll say let remainder equal to a remainder b. And then we'll print out what the remainder is. And it should print out 2. So the arithmetic is super simple. The remainder one is one you might not have seen before. So the percent sign is how you get the remainder. And now you've learned the basic scalar types of Rust. In the next lecture, we're going to talk about the compound types, such as tuple and arrays. So I'll see you then. In this lecture, we're going to talk about compound types. Compound types can group multiple values into one type. And Rust has two primitive compound types, tuples and arrays. So we're going to start with what a tuple is. A tuple is a general way of grouping together a number of values with a variety of types into one compound type. Tuples have a fixed length, so once they're declared, they cannot grow or shrink in size. So let's look at what a tuple is. So we'll say let tup equals parentheses, and then remember, they can be a ton of different values, so we'll just give them one an integer, one a string, and then one a Boolean. So how can you access these information, these data, inside the variable tup? So what we can do, and we'll just print it out, is set up our normal stuff, and then if you type tup period, you see you have 0, 1, 2. So the way counting works in programming is the first element, which in this case is 500, always starts at 0. So we'll always go 0, 1, 2. And it works the same way in arrays and vectors and so on. So the index of this is going to be 0. So if we typed out 0 and then we built it and run it, we see 500. But the same thing works as if we did 1. And also if we did 2. So that's how you can access the information inside of a tuple that way. But say you wanted to assign each value inside the tuple to a different variable. So we'll say let x, y, and z equal tup. So now we can inference that x is going to link to 500, y is going to be assigned to high, and z is going to be assigned to true. So to test this out, let's print out the values, and let's see what happens. So we have x, and then we will copy and paste y, z, clear, cargo build, cargo run, and now we see that we have x is 500, y is high, and z is true. So that is how you can use a tuple to assign multiple values into one type, and then you can also pull those values out and assign them to different variables. In the next lecture, we're going to look at arrays, which is another way to have a collection of multiple values that all have the same type. Another way to have a collection of multiple values is with an array. Like a tuple, arrays are going to have a fixed length. But an array is different from a tuple because every element of an array must have the same type. Now there are a couple different ways that we can set up an array, with the first one being, let's create an array variable, give it some brackets, and then we're going to create an array that holds integers. So here we created our first array and assigned values 1, 2, and 3 inside of it. Now, like a tuple, arrays are also going to start counting from 0 when you are referencing their index. So index 0 is going to contain the value 1, index 1 is going to contain the value 2, and so on and so forth. So if we wanted to access one of the values inside the array, we will say array, open and close bracket, and then we will give the index that we want. So what this is going to do is it's going to access the first element in the array for us, which in this case is 1. And that's exactly what we got. Another way that we can set up an array is saying, hey, I want an array, but this time I want it to be of signed integer, 32 bits, and then I want it to have a specified length of 3. And then in here, you do the same thing. So we'll give it another 3 values, and in this case it is 4, 5, and 6. And it works the same exact way as before. So now what happens if we want to modify a value inside of an array? So if we came down here and said array2 of index 0 equals 10, that would be me trying to change the value 4 to the value 10. So do you think this will work, or will we get an error? If you said you think we will get an error, you are correct, because we did not make our array mutable. And luckily, if you happen to make this mistake, the Rust compiler is friendly enough to tell you, and it tells you, hey, you need to make your array mutable. So now if we go up here, make it mutable, and then try it again, we're good to go. So we changed the first value in the array from 4 to 10. Now another thing is what happens if we try to reference an index outside of the array? Meaning, since we only have 3 values, the highest index we should technically be able to go is 2. But what happens if we tried to reference index number 3, which does not exist in this case? So if we do that, what do you know? The Rust compiler is smart enough to tell us, hey, prior to runtime, you tried to reference an index that doesn't exist. So it's already doing that checking for us, but what happens if we did it dynamically at runtime? Well, it tells us right here, this operation will panic at runtime. And that is really good for us because we can actually handle panics in our code, which we will get to later in this course. And the big deal behind this is it's going to prevent the user in our program from being able to access unauthorized memory. So the Rust compiler is really good, and it's also very smart at being able to check our code prior to runtime to hopefully help us catch bugs before we put them into production. Vectors are a resizable array of elements allocated on the heap. Vectors are an essential type in Rust because they are used almost anywhere one needs a list of dynamic size. The easiest way is to use the vec macro, and as a reminder, we will talk more about macros later on in this course. But for now, let's just look at how to create a vector using the vec macro. So I went ahead and created a new variable called nums, and we are going to use the vec macro to create a vector. So I'm going to put in the values 1, 2, and 3, and now remember, I said that vectors are resizable. So let's add a value into this vector already and call it and give it the value 4. So now let's print this out and see how it works. Nums. Now this is going to produce an error, but I want you to see the error so that we can understand why it's an error. So it says vec of type integer cannot be formatted with the default formatter. So if we continue reading down, and this is just showing you how helpful the Rust compiler is, it will say you may be able to use a colon and a question mark instead. So basically what that is that's going to allow us to put it into debug mode. That's what the question mark is, and the colon basically says take the next thing and then push it into the formatter and output it into debug mode. So now that we have that in there and we cargo build, don't forget to make your variable mutable since we are changing it by adding in another number. And now we can see we have the values 1, 2, 3, and 4 printed out. But we can also remove values. So we can use the pop method that a vector provides us. And what pop is going to do is it's going to take the last value that we pushed into the vector and remove it. So let's pop one and then let's print it out. And it should remove the 4 from the vector, which is exactly what it did, which is awesome. So there is another way that we can create vectors, so let's go ahead and do that, and it's called vec_new. So when we use the vec macro, this is essentially what it's calling is the vec_new constructor. So now that we created a new empty vector, again, we can push values onto here. So let's call it test, and then let's push on string. Let's print it out just to make sure that we are working correctly. Clear it, build it, run it, and we have test string. So now what's really cool about vectors, they come with a ton of methods that we can already use. So I highly encourage you to explore all these methods after this lecture just to really familiarize yourself with everything available in the vector class. So what we're going to do, just for an example, is reverse the vector that we created. So by doing this, we should see when we print it out, string test, which is exactly what we got. We have string test. So again, I highly encourage you that after this lecture, just play around with all the different methods that a vector provides and just really get familiar with them, as they will help you in your Rust career. So another really cool thing that we can do is if you know the size that your vector is going to be, we can actually specify that. So let's start off with a new vect, and we'll call this one vect. And we're going to say vec. Now we have to give it a type since we are creating it empty in this case. So I'm going to give it integer 32 with capacity 2. And then I would just want to print out, just to make sure that it created that capacity, vect dot capacity. There we go. So let's build it. Okay, we have an issue here. It says use fully qualified syntax. So we said let mute vect of type I32 with capacity 2. Let's see if we can use the compiler to figure this issue out. So I know that this one's not going to work, and it's because we needed greater than and less than around it. So now that we use the compiler to figure it out, let's go ahead and run it. So down here it says 2, which is what we set our capacity to be at. So you might be wondering, well, if I create a vector with capacity 2, what happens if I end up needing extra capacity? Luckily, the vector can grow if it needs to. And the way it works is it's going to allocate a larger buffer, copy the present contents into the new buffer, and then it's going to update our vector variable to point to the new buffer, and then it's going to free the old vector from memory. So basically it's just going to get a new region of memory, push everything into it, and then delete the old. So that way it's very seamless for us to be able to expand it as we need to. And then one other trick I want to show you is you can actually create a vector using an iterator. And we will talk about iterators later on in this course. So we'll say we want to create a vector from values 0 to 5, not including 5. And let's go ahead and print it out. And it should give us values 0, 1, 2, 3, and 4, which is exactly what we got down here. We have values 0, 1, 2, 3, and 4. So again, I highly encourage you to play around with all the methods available to vectors to really familiarize yourself with them. It is a very essential type in Rust, and it will immensely help you as you continue to learn Rust. In the next lecture, we will talk about what slices are. A slice is a region of an array or vector that can be any length. Slices cannot be stored directly into variables or passed as function arguments. So let's start off by creating our first slice. And I'm going to continue off the vector example we had in the last lecture. So we're going to say let SV, and S is for slice, a reference of type I32 equals a reference to the vector we created above. So now I know I said that we cannot store slices directly into a variable, and that's not what we're doing here. So what we're actually doing is we are pointing the variable to the address in memory where the slice starts. So currently we're pointing SV to where our slice starts, and our slice in this case is going to be all of the vector we created above, and that reference to the slice is called a fat pointer, which is a two-word value comprising a pointer of the slice's first element and the number of elements in the slice. So now let's just go ahead and print out the vector above. And then let's go down here and let's print out our slice. So you can see they're the same exact thing because we are pointing to the entire vector as our slice. But if I wanted to, I could point to, let's say, elements 2 to 4. And now you can see that's exactly what I get. I get only 2 and 3 now. So we have created our first slice. So the SV variable is going to point directly to the data in vector V, and it is going to be a non-owning reference. And references and ownership, we will all get to that a little later in this course. So if it doesn't make sense right now, that's okay. I just want to introduce some of these concepts to you. That way, when we get to that point in the lectures, it's not a brand new introduction. So continuing on a little bit more about what references are. An ordinary reference is a non-owning pointer to a single value, but a reference to a slice is a non-owning pointer to a range of consecutive values. So again, a ordinary reference points to a single value, whereas a slice points to a range of consecutive values, both of which are non-owning. So what are slice references good for? Well, when you want to write a function that operates on either an array or a vector, that is when you want to use a slice. So again, if this didn't make complete sense, it will when we get a little later on into lectures. It is just something that I wanted to introduce to you prior to getting into strings, which I will begin talking about in the next lecture. Strings are very similar to vectors since they are stored as a vector of bytes. The difference is that strings are guaranteed to always be a valid UTF-8 sequence. A string will be allocated on the heap, is growable, and is not null terminated. There are a couple of different ways you can allocate a string. The first one, we will create a variable called name and say string from, and then we will provide the string. And then if you just hover over string, it'll tell you it is a UTF-8 encoded growable string. Another way that we can create a string is say let course equals Rust to string. So both of these are the same thing. They're both strings. They're both on the heap. They're growable, and they're not null terminated. So what we can do, much like vectors, is we can modify strings. So let's change my name, and we'll call this variable new name, and say we want to name replace. We want to go from Tyler, and then we want to change it to Ty. So let's just go ahead and print all these out and see what we get. So we have name, and then we will copy and paste it 2 more times. We have course, and we have new name. So let's go ahead and build it. We have Tyler, Rust, and Ty, which is what we were all expecting. So now we also have what is known as a string slice or stir. So we'll put in here and str equals string slice or stir. So that's how you can pronounce that. And much like a slice in a vector, it is going to reference and borrow the text from the variable. So like other slice references, it is a fat pointer containing both the address and the actual data and its length. You cannot modify a string slice. So let's see how you can create a string slice. So we'll just call this string1 and we'll set it to hello. And that's all you have to do. This is an string slice. So just to prove it to you, in case you don't believe me, we're going to do a nifty little trick on how to get it to point out. So we'll just come in here and type in a bogus method. So this will obviously produce an error in the compiler. So let's go ahead and build it. And as you can see, it produced the expected error. And you can see that our type is a string slice. So you might be wondering when to use a string or a string slice. And for now, it will suffice to say that a string slice can refer to any slice of a string, whether it is a string literal or a string. And I will show you what a string literal is in the very next lecture. So what it means is that a string slice is more appropriate for function arguments when the caller should be allowed to pass either kind of string, so either a string or a string literal. And remember, a string slice does not allocate memory on the heap where a string does. But we can also flip-flop between string slices and strings. So we have our string slice here, so let's create and say string 1 dot to string. So now we just converted string 1 into a string and stored it inside of string 2. And now let's turn string 2 back into a string slice. So we will go and str2. So now if we print all these out, every single one of them is going to print out hello. And all we did was bounce back and forth between a string slice and a regular string, which is exactly what happened. So much like vectors, strings have a ton of methods already associated with them. We can compare strings using the double equal signs to validate if the strings are equal to one another, or exclamation point equal signs to mean does not equal. So we're trying to make sure two strings do not equal each other. So just to show what this might look like, let's go ahead and print it out, a sample. So we're going to check if 1 dot 2 lowercase equals 1. So we're going to take all capital 1, change it to lowercase, and then compare it and see if it equals to all lowercase 1s. And so we would expect this to return true, which is exactly what we get down here. So everything returns true. So those are the basic fundamentals of strings and string slices. We will continuously use these throughout the course, so you will be getting more than enough experience using them to gain familiarity and just get more comfortable with when to use what and where. But I do encourage you, prior to going on to string literals, play around with string some and look at all the methods that are associated with them. And when you're comfortable with it, continue on to the next lecture of string literals. Alright, so to wrap up strings, let's talk about string literals. So as I said, strings and string slices are always going to be a valid UTF-8 sequence. Well, sometimes you might not want a valid UTF-8 sequence, and that is where string literals are going to come into play. So let's take a quick example of what a string literal might look like. So we're going to create a variable called Rust. We're going to put double quotes around it, and then we're going to use the backward slash, and we're going to say, in this case, I'm going to go x52, x75, x73, and x74. So these are all special characters, x52, x75, 73, 74, and I'm using this backward slash to escape those special characters. So let's go ahead and print out what we just typed. Cargo build, cargo run, and we typed out Rust, but we did it a super fancy way. So again, string literals you will want to use when you don't want to have valid UTF-8. Alright, now let's talk about function. Functions are an important aspect in every programming language. We've actually already been using a function through our program, and that is the main function. And remember, early on in this course, I said that the main function is the entry point to the program. And as you can tell by the main function, we define a function by using the fn keyword. So when we are creating a function, Rust is going to use what is known as snake casing as the conventional style for function names. Snake casing is all letters are lowercase and underscores are going to separate the words. So an example of this would be, this is snake casing. So everything is lowercase and all the words are separated by underscores. So let's create a simple function that will print out a phrase from our function. So we're going to use the fn keyword to signal to Rust, hey, we're about to create a function, and we're going to call it print phase using our snake casing. So following the name of our function, we're going to have an open and a closed parentheses, and currently there's nothing in there, and then we're going to have an open and a closed bracket, and that's going to basically signify the scope of our function. So everything inside of these open and closed brackets is going to belong to our function, and in this case our function is print phrase. So now let's go ahead and create a print statement that is going to say hello from the function. So now let's just go up here, and to call our function all we have to do is type in the name of our function. And I'm going to get rid of the default hello world. So all we have now is just saying, hey, print phrase, call our function, which is the open and close parentheses. That is how you say, hey, I want to call my function. So now we can run cargo run, and we see we got hello from the function. So sweet, we got our first function done. Let's continue building on that. So now inside these open and close parentheses, we can add what's called arguments or parameters. Arguments and parameters are just interchangeable words. But inside of here, we can add in special variables that are part of the function's signature. So when a function has parameters, you can provide it with concrete values. So let's create a variable inside of here, and we'll call it phrase, and we're going to give it a string slice, or a reference to a string. So inside print phrase, we're going to say, hey, I want you to print my argument. Alrighty, so now we're passing in an argument. So down here, all we have to do now is print our variable like we've always done, which in this case, our variable is phrase. So we're just creating our argument up here, passing it down into this phrase variable through a string slice, and saying, hey, I want you to print it out. So now if we cargo run it, success. We have successfully printed out our argument of print my argument. So now another functionality that functions has is we can return values from it. So I'm going to comment all this out, and let's do a fun little function of the greatest common denominator, a very well-known little algorithm. And what we'll do here is we'll give two values, and we are going to return the greatest common denominator between those two values. And inside this function, we're also going to get a look at some control flow statements, which is what is going to be the topic of our next lecture. So let's create our function, call it GCD, and we're going to create a mutable variable a, and give it a value of unsigned 64 integer. And then we're also going to create a mutable variable b, and also give it an unsigned 64. Now to return a variable, or to return a value from a function, you use the little arrow, the type that you want to return, which in this case is going to be unsigned 64, and now we fill in our function with the logic. So we're going to create a while loop, and while a does not equal to 0, and then if a is less than b, and again, we will get into depth about what these control flow statements are in the next lecture. I just want to show you kind of a little fun example of creating a function. B equals C. Come down here. A equals A. Remainder B. And then we want to return B. So now all of our errors that it was saying that we had are now gone. So to return a value, you put it at you signify it by not including a semicolon. So we can return values, and as we continue to grow and continue our Rust journey, you will see that you can have more than one return value in a function, but depending on your logic, only one value will be returned. But you can have return values in multiple places. In this case, it happened to be at the end of our function, and we signify that it's a return value by leaving off the semicolon at the end. So now we'll go up here, and we will say GCD, and we're going to pass in two parameters. So for our first parameter, let's pass in 20. And then for our second parameter, let's pass in 5. but we also want to print this out, so let's just go ahead and put it inside of a print statement. That way we can verify our work is correct. And now let's run it. So awesome, we got the GCD of 5, which is correct. So now let's, just to verify, let's change it to 4 and make sure that it's now 4. Awesome. So we now have a working greatest common denominator function. And since I went ahead and brought it up, I do want to just go ahead and show you how you can have multiple return values. And I want to pass in a, I'll call it flag. I want it to be a Boolean. I want it to return a Boolean. So in this case, if flag equals true, I want to return true, else false. So what I'm basically saying here is if the flag that I pass in is true, return true, else return false. So we have two return values in here. We have a true value that can be returned and a false value, and it's going to be dependent upon what I pass in here. So just to show this to you, let me go ahead and say I want you to print out my multiple return value, and in this case we're going to print out true in this one, cargo run. So we have true, and then if we come up here and say false, we now printed out false. So as just an example of how you can print out multiple potential return values, it'll be through control flow statements, which we will cover in the next lecture. Control flow is all about deciding where to run code based on if a condition is true or not, or deciding if to repeatedly continue running some code while the condition is true. This concept is a fundamental building block in programming. The most common control flow statements in Rust are if statements, and then there are 3 types of loops. So let's go ahead and look at what an if statement is. So we'll start out by saying let 1 equal 1, and then we can start an if statement with the if keyword. So we'll say if 1 is greater than 0, print out true. So we are checking to see if the condition 1 greater than 0 is true. But if it's not, then we want to print out false. And that's what the else keyword does. Else is going to be our fallback plan. If none of these other conditions are true, then this is the block of code that we want to evaluate. So we know that 1 is greater than 0, so we got true. But if we said is 1 greater than 10 and we ran it, now we fall back to our fallback plan of false. That way we have logic for if any of our conditions are not true. Another thing that we can do is we can chain in multiple conditions. So with the else if keyword. So now we can say is 1 equal to 1. And if it is, we want to print out equal. So now if we run this, we expect equal to print out, and that's what we get. And you can have as many else if chained together as you want in order to accommodate for all possible conditions that your program might have. And that's just the basics to the if statements. So now let's go ahead and start looking at some of the loops. So we'll comment that out. And the first loop that we're going to look at is a while, or correction, is a loop, with the keyword being loop. So to show you what a very simple loop is, we'll say, hey, I just want you to print out loop. And this is going to be an infinite loop of the word loop, printing out. And as you can see, that is what we're getting. So we can do Control-C at the same time, and that's going to send an interrupt to our program so that we can exit out of our infinite loop. So now let's get a little bit more sophisticated with this loop, and what we can do is actually we can give our loop a name. So in this case, I'm going to name a loop called counter. And then inside this loop, I'm going to print out the count. And I'm going to set it to num. And I need to create the num variable. So we'll say let mutable num equal to 0. And then what we'll do is we'll create another variable on the inside. Let mutable decrease equal to 5. And then we're going to create another loop inside of our loop. So now we have a nested loop, and you can have as many nested loops as you want. The more loops you typically have will start affecting your big O notation, which is the spatial and time complexity that your program may have. So inside this loop, we are going to print out decreasing and point that to decrease. And then we're going to add in some if statements. So if decrease is equal to 4, break. So this is our first keyword inside a loop. So what break is going to do is if this condition is true, then we're going to break out of the loop. And the loop that this break is referring to is the loop that we're currently running in, so the innermost loop. But now we're going to create another if statement that says if num is equal to 2, so our variable up here, then we want to break out of counter. So this break is actually referring to our outer loop, which we named counter. So what we're going to do now is we're going to decrease by 1. And what this statement is saying is essentially decrease equals decrease minus 1. It's just shorthand for it. And then outside of our innermost loop, we want to add 1 to num. And this is the same thing as saying num equals num plus 1. So now if we run this, we see that down here we started out with our count at 0. That's correct. And then we decreased from 5 to 4, which is correct. So we enter this loop with our decrease at 5. Decrease is not equal to 4, so we don't execute the break. Num does not equal to 2, so we do not execute this break. But now we decrease by 1 and we stay inside this loop. So now our decrease is 4, and now we can break out. So we break out, we increase our count, so our num by 1, which is what caused this count to now print out 1, and we repeat the loop again all the way until our count equals to 2, and then when our count equals to 2, we satisfy this condition, which lets us break out of our outermost loop, which we named counter. So you can have as many loops as you want inside one another, and then based on your logic, you can stay in a loop as long as you want, and then you can set up logic on the inside to be able to break out of loops when conditions are met. So another type of loop that we're going to look at is called a while loop. And a while loop will run while a condition is true. So to very simply show this one, we're going to say while. Well, first off, let's create a mutable num equal to 0 again, and then we'll say while num is less than 5, print out num. I want the value. We'll reference our number, and then we will add 1. So now we'll run it out, and you can see that we printed out and got 0, 1, 2, 3, and 4. And once we hit 5 with num, our condition was no longer satisfied because 5 is not less than 5. So we broke out of the loop. But now if we said less than or equal to 5 and then ran it, now we also included 5. And that's how a while loop works. So now let's look at a for loop. And a for loop is a great way to loop over elements of a collection. So think of a vector. So let's do vec of i8 equals to 0 to 10, and then we want to collect those values and put them in there. So then for element, so to start a for loop, we use the for keyword. Element is going to be our variable for accessing all the values inside. So for element, aka all the values inside our vector, in, and then what's our actual vector's name that we want to reference? Well, it's vec. So for all the values in vec, let's print them out. Print line. And then we want to print out what the element is. And as you can see, we printed out 0 to 9, which is what we expected. So now a fun little cool one that I can show you is we can create a for number in 1 to 4 and then reverse it. Print line and then we want number, and then afterwards, when our countdown is done, we have liftoff. Clear, run it, 3, 2, 1, liftoff. So we created 1 to 4, not including 4, reverse it, print it out, and then exit the loop and provide or print out liftoff. And that's all it is to loops. So loops are very powerful. You're going to use them all the time throughout your code. But now we have successfully gone over all the basics of programming. Congratulations on completing this section. These are all very important fundamental concepts that are essential in being a great programmer. I know we learned a lot in this section, but everything we did, we will use in the remainder of this course and continue to build on. If there are any topics you still don't feel comfortable in, please rewatch those lectures or ask questions in the Q&A section. It is highly important that you have a good understanding of these concepts before continuing on to Section 3. But once you are ready for Section 3, I will see you there. Once again, congratulations on learning these fundamental yet very important concepts. I hope you enjoyed this assignment and the questions that it involved. Each question was progressively getting more challenging than the previous one. So, in this video, I'm going to go over the solution to each question. If you have any questions about my solution, please ask them in the Q&A section. So question 1 states, create 3 variables with the names val1, val2, and ants. So let's go ahead and do that. Okay, so now we have our three variables. We want to perform a simple operation of generating the modulo for value 1 and value 2. And we state that we need to assign the answer to the ants variable. So we know value 1 is going to be value 5, and value 2 is 2, and then we say let ants hold the answer to the modulo of val 1 to val 2. So I believe the answer to this is going to be 1, so let's print this out and verify that that is correct. And we want to print out ants. So now we do cargo run, and we see the answer is 1. So we have question 1 completed. Question 2 is create a vector and put the values 2, 4, 6, 8, and 10 inside the vector. So for us to do this, we can say let vec equals, and then we can use the vector macro since we know what values we want to put in, and we will put in 2, 4, 6, 8, and 10. So a very super easy way for us to create a vector. And then once we have created our vector, we want to print out the current values. So to print them out, we will use the print line macro. And now we will print out the vector. So let's make sure our vector printed out, and we see we have 2, 4, 6, 8, and 10. Now we want to remove the value 10, add the value 12, and then print the vector back out to confirm our results. So to print it back out, we will copy and paste. And now we want to remove the value 10. Well, we see 10 is the last value added in, so we can very easily remove this value by executing the pop method on it. And now we can add the value 12 by using the push method, and if we run this, cannot borrow is mutable. So what we need to do in order to mutate is we, aka change the values inside of the vector variable, we need to add the mut keyword to it. So now if we run it, we see that we have 2, 4, 6, 8, and 12, which is the desired output. So again, anytime you want to mutate a variable or change it, you have to have the mut or mut keyword added to it. For question 3, we want to create a function called concat string. Okay, so concat string, and then inside, in our main function, we want to create a string variable. So we will say let str1 equals a string from, and we want the value hello. The function is going to take one argument that is of type string. So in here we'll have our val that is a string, and we are going to return a string. So now we are returning a string. And then inside the function, we want to concat the string world to hello. So what we want to do is say val plus world. And now if we come back to main and we say let ants equal concat string of str1, and now if we print out ants again, we see that we successfully concatenated with hello world. And in case you might be wondering how come we were able to use ants down here and up here, because we reinitialized ants here, so the value up here is no longer valid. Ants will now only be referred to by our value down here. So now we have successfully created a concat string function that will concatenate strings together. And then our last question is create a function called control flow. Okay, so we have control flow, so we created our function, and this is going to take one argument that is an integer, so we will say val and we'll just give it I32, and then based on this integer print out the following: the value is 1, the value is greater than 50, the value is less than 25, or the value is greater than 25 but less than 50. Okay, so inside of here we want to check if val is equal to 1, then print out the value is 1. And we're going to have a couple of print statements, so let's go ahead and do this. Else if val is greater than 50, print out the value is greater than 50. Else if the val is less than 25, we want to print out the value is less than 25. Else print out the value is greater than 25 but less than 50. So now if we call this function control flow, let's pass in the value 5 and let's see what is returned. The value is less than 25. That is correct. If we pass in 500, the value is greater than 50. That is correct. If we pass in 1, the value is 1. That is correct. If we pass in 25, the value is greater than 25 but less than 50. And that is also correct because we did not use an equal sign here or here. So now if we run this, we will see the value is less than 25 because now we are also including the value 25. So hopefully you were able to understand and accomplish these questions with ease, and if you were, then you are definitely ready to move on to the next section where we begin talking about ownership.